Hello, my name is Evan Fink. I'm going to walk you through a project in Tableau that I put together for Quinnipiac University's Business Analytics course, BAN 650, Data Visualization. On the right is a picture of me with the Spirit Airlines first A320neo aircraft. The airplane model entered service in January of 2016 in Germany, and in the United States that October. I had the opportunity to greet this airplane after its second revenue flight, where it landed in Detroit Metropolitan Airport. There are a number of websites that include flight data across the globe. For this project, I signed up for a business account on Flight Radar 24, which grants access to 365 days of flight data. I pulled the data from the available 89 Airbus A320neo aircraft, which includes over 60,000 flights over that 1 year. The data pulled from Excel roughly looks like what you can see here, which has been filtered to show the flight that I got to visit. It includes date of flight, flight number, city pair, scheduled and actual times of departures and arrivals. As you can see here, I can change the filters to show any other data. For example, we'll just look at another airline. There's Lufthansa on that same date range. The data set includes a large amount of information that is useful to companies supporting the airline. There are two different variants flying today, the 251N, which is powered by the GE's CFM LEAP 1A26, and the 271, which is powered by Pratt & Whitney's PW1127G-JM. Illustrated here are the number of flights per airline and the number of aircraft per airline. Blue shows airplanes powered by a Pratt engine, and gray shows the GE engine. Here we can see where the aircraft are operating out of. The GE engine dominates Turkey, Scandinavia, Thailand, and Malaysia, while the P&W engines are most popular in India, Germany, and Mexico. This difference is based on the operators that have selected the two aircraft. And here we can see each operator has a different color. If you look at the United States only, you can see that US-based Spirit and Frontier are competing in the United States, as well as Mexican-based Volaris for some southern flights. If we highlight Spirit, you can see that they are based at all the different points where they're traveling out of. Spirit is based out of Fort Lauderdale, but they have major maintenance bases in Dallas, Fort Worth, Texas, as well as Detroit, Michigan. Sometimes when you look at data, you think that you're looking at a lot of data. I want to quickly illustrate how small 60,000 flight is compared to global commercial flights. There are about 35 million flights globally in 2016. This thin blue strip, which doesn't really show up well, is all of the non-US operators flying the A320neo, and the two small blue squares represent Spirit and Frontier Airlines' use of the aircraft compared to the rest of their fleets within the United States. Flight duration is an important factor for business and technical solutions on an aircraft. Shown here is a histogram which shows short flights under an hour, a bucket from 1 to 2 hours, and so on. So this is 3 to 4 hours. This helps to identify some bad data in the data set. I've taken the exact same chart you just saw and put it on a logarithmic plot. And when I show all of the data, you'll see there's a bunch of nulls, and there's also some errant flights out here in the 17-ish hour flight range. I spot checked a few flights in each bin and found that there were errors in the data. Most seem to be time zone and AM/PM errors. We'll avoid looking at those going forward. A tree map is an interesting way to show how much each operator is using the aircraft. It is a bit busy with the operator names, but it helps to understand the message. So these are all the different operators. And, we have LATAM and Hong Kong down here as well, some other airlines. This helps to show just how much each operator is using the aircraft. And here's a little bit cleaner visualization. Without the operator name, you can get a good idea of who is flying more often, both in terms of number and of length of flight. Again, flight duration is somewhat critical. Here we can see a box and whisker plot by operator. Lufthansa seems to be using the aircraft for short flights inside Europe, while Hong Kong Express has a median flight length of over 3 hours. Another interesting trend to observe is the number of flights for the fleet over time. Here we can see when each operator came on board. Lufthansa and Indigo started in January of 2016, so they predate the data I could obtain. But again, you can see Spirit starting in October. We can filter it too. Right, so I was there in October when they started flying. So this exercise provides many important and helpful facts that anyone supporting the A320neo aircraft could utilize. This is just a summary of some of the charts we've seen. I'd like to thank the sources shown here. Here's what some of the data looks like on Flight Radar 24. After I saved the data to Excel in separate tabs for each aircraft, I created a union to join it all in one data set. This is kind of what the data with a lot of calculations looks like. I then joined the data from Airfleets to give me aircraft serial number, airline, and aircraft type. To manipulate the dates, I had to create a string out of the date. So here's me creating that string. When I converted back to date, Tableau automatically revised the calculation to something more complicated, but it kept it working. So the code that I just showed you turned into this in Tableau. So it was just an interesting finding. I started getting errors when I made a lot of equations. I think the 60,000 cells times, 10 or 15 really complicated equations bogged down Tableau. So I ended up saving it to a CSV file and pulled it back into the file I shared with you today to make it run quickly. I was able to use charts, especially the histogram, to find errors in my data. One of the biggest errors I found, so this is what the histogram looked like before I fixed the data, and this is what it looked like after I fixed the data. The problem was the UCST for time zone means both Chinese Standard Time and Central Standard Time in the United States. So the two are off by 14 hours there. So I'll show you the fix that I put in to correct for CST. So this is my calculation for actual time of departure. So it's a if and then statement, kind of a big one for any time zone to add the hours and in some cases minutes if need be. The fix is highlighted here. So what I end up doing is taking any airline that's US based, also Mexico and Brazil, and I use CST for them as the Central Standard Time in the United States. And every other operator, I set it to Chinese Standard Time. I also had to correct for if the day went over, so if the flight went overnight and into another day. This is the correction I used to show 2 different day flights. I learned that I could join airport information twice, once for departure and once for the arrival location. So it was helpful to use Tableau here. Going forward, there are many more interesting graphics that could be assembled from the data set. This includes the number of flights per day, how late or how on time each flight was, the number of diversions or other non-standard occurrences, as well as a map of the city pairs. Thank you very much for watching.